We're now going to cover Java's predicate functional interface. In this part of the lesson, we'll describe the structure and functionality of the predicate functional interface and also show how it can be used in conjunction with Java lambda expressions and/or method references. As usual, all the code examples we're going to walk through can be found in my GitHub repository in open source form. These examples will also showcase some of the interesting features and classes in Java's collections framework. So what is a predicate? Well, as with mathematics, a predicate performs a test that returns either true or false. In Java, you can see a predicate is an interface that's a generic interface that's parameterized by one reference type. It also has a single abstract method called test that takes a parameter of type T, which is the generic parameter, and returns Boolean as the result of applying the test. The signature of this abstract method in this functional interface, and any functional interface that for that matter, is called the function descriptor. And it describes the signature of the lambda expression or method reference that can be passed to a method that takes an instance of predicate. To make this all more concrete, let's take a look at an example in my ex10 folder in my Java 8 directory in my GitHub repository. This particular example will start off with a factor method called makeMap. And this is going to be part of a sort of a whimsical running example we'll use here that involved the Three Stooges, which is a comedy act from many, many years ago that made a lot of money and made a lot of fame by making movies and short clips where they pretended to be really dumb. Of course, they were actually pretty clever and pretty smart to figure out how to make a lot of money doing that. You can take a look at the link at the bottom of the slide to learn more about the Three Stooges. So makeMap returns a map that maps a string, which is one of the Stooges' names, to their notional IQ. And you can see that we implement this map with a concurrent hash map, and we're also going to initialize it and provide initial values for Larry, who gets the IQ of 100, Curly, who gets the IQ of 90, and Mo, who gets the IQ of 110. He was always the smartest of the Stooges. We then invoke the makeMap factor method and make ourselves a local variable called Stooges, which is this map that maps string to integer. After printing out the values, we're then going to use a predicate lambda to remove all the entries in the map whose IQ is less than or equal to 100, namely Larry and Curly. Good old Mo will stick around. The way we do this is we call stooges.entrySet, which will get the set containing the values in the map, which is of type entry, which maps string to integer. And then we call the removeIf method. RemoveIf was added in later versions of Java from Java 8 onwards. And it's going to take a predicate as its parameter. And this predicate, as you can see here, is going to say entry arrow entry.getValue less than or equal to 100. Now, this lambda that we're providing, this predicate lambda, actually implements the abstract test method of the predicate directly in line. So it conforms to the function descriptor of the predicate. Entry, you see here, is actually shorthand for entry string integer entry, which is essentially the full type. And the entry shorthand here is actually allowed by something called Java type inference. Modern Java compilers can figure out that you actually refer to the entry element in the map when you use the shorthand entry. Let's now go ahead and take a look at the removeIf method implementation, or at least a snippet of it that's part of the collection interface in Java. So first thing to note, the name of the method is removeIf. Second thing to note, it takes a predicate, which is called filter. And the third thing to note on this slide is that we then say filter.test when we iterate through each of the elements that's in the collection and see whether or not we're going to remove the item if it matches the test. Another thing to note here is that we use the default keyword. Default methods in modern Java interfaces, namely Java 8 and beyond, enable additional functionality to be added to the interfaces of libraries, thereby ensuring binary compatibility with code written for older versions of those interfaces. In earlier versions of Java, namely Java 7 and before, you couldn't provide implementations in an interface, only the declarations of methods. But with Java 8 and beyond, you can actually provide default implementations. And that's what we do here. That's what Java does here. We're then going to go ahead and show a little bit more syntactic variant in Java, which is the question mark super E syntax, where the keyword super is a so-called lower bounded wildcard that restricts the unknown type, or the type that will be provided when you instantiate the generic, to be a specific type or a super type of that type. So you'll see how this works when we actually instantiate this in just a moment. So here's a little bit more mapping of our original example onto the implementation of removeIf. If you recall, when we called removeIf, we passed in this predicate lambda that was basically entry.getValue less than or equal to 100. And that's essentially what's bound to the filter parameter that's passed here as a predicate to remove if. This is how it actually gets used in the implementation. The implementation will create an iterator to iterate through each element in the collection. And then while the iterator hasn't finished, we check each element in the iterator one at a time by calling filter.test. And if the test passes, if it returns true, we'll go ahead and remove the item from the collection. So that's how we use the test method. So it's almost as if this had been inline to say, if each.next.getValue less than or equal to 100. Let's now talk a bit about how you can compose predicates, because that's an additional feature that's added with modern Java. So you can compose predicates. We're going to stick with our example of the stooge map. And what we're going to do here is we're going to go ahead and create a couple of predicate objects. And you can see here that we're going to have one predicate that's going to be called IQ. And that's going to be bound to this predicate lambda that says, is the entry's value less than or equal to 100? So that's going to be the IQ or IQ range that we're interested in. And then we're also going to define another predicate we call curly. And curly is going to be set to a predicate lambda that will be the entry's key, whether it equals the name curly, the string curly or not. So that's what the curly predicate will be. So armed with our IQ predicate and with our curly predicate, we can then say stooges.entrySet.remove if IQ and curly. So what this is saying is if the IQ is less than or equal to 100 and the name, the key value is curly, then go ahead and remove that item from the stooges map. So that'll just kind of illustrate how these different predicates can be composed together using the AND operator that's defined as part of the predicate interface. Notice that that is not an abstract method. The abstract method is test. This is another non-abstract method. So that's the end of our coverage of Java's predicate functional interface. Hopefully you have a better understanding of how it works, and hopefully you enjoy the whimsical example of the three stooges, which are always good for a laugh.